Hey guys, welcome back to the channel. Look at these transistors here. Do you observe something that is common in all of them? Yes, you guessed it right. They all have 3 terminals in them. But haven't we mostly come across electrical components having only 2 terminals? Then why this 3rd terminal? Just so you know, there are electronic components with more than 3 terminals also. Although, in today's video, we'll be essentially discussing the functions of the 3 terminals of a transistor. But before we move forward, let's brush up on some points. Transistors are essentially semiconductors and are of 2 types, PNP and NPN. In an NPN transistor, a p-type semiconductor is sandwiched between 2 n-type semiconductors. Similarly, a PNP transistor has an n-type sandwiched between 2 p-type semiconductors. These form the 3 terminals of the transistor: the emitter, the base, and the collector. One of the main differences between an NPN and a PNP transistor is that in an NPN transistor, the current flows from the collector to the emitter, and in PNP, the current flows from the emitter to the collector. The semiconductors gain their specific types because of the dopants that are added. Dopants are impurities that are added to a pure semiconductor in order to change its conductivity. To know more about these types, you can check one of our previous videos, the link to which is given below. The first terminal that we will discuss is the emitter. The emitter is the highly doped terminal of the transistor. This means that they have a large number of free charges. This is done because the emitter has to emit charges into the collector through the base. A large number of free charges would mean more charges being present to conduct electricity. Next, we have the base terminal. The base functions as a trigger for large emitter-to-collector current. When the base receives sufficient voltage, a large current flows through from the emitter to the collector. It starts operating at a minimum voltage of 0.7 volt. We can easily manipulate the amount of voltage at base to change the flow of current through the transistor. The base region is thinner when compared to the emitter and collector junctions and is lightly doped. This is to facilitate the easy flow of charges. Since this region is lightly doped, they offer very less electrical resistance. Finally, we have the collector. The collector region attracts the charge carriers. In case of a PNP transistor, the current flows from the emitter to collector and then out from the collector. This region is moderately doped and the size of the collector is slightly larger than the emitter. This is to allow the collector to dissipate heat so that the transistor doesn't burn out. Now that we know that the transistor has 3 regions, here are 2 commonly used NPN transistors. Can you identify the emitter, base, and collector in them? Well, let us help you. First, let us take this transistor. Take a look at this region here. Most transistors have one of their side flat-faced and the other side round. Here we have an NPN transistor. If we face the flat side towards us, then the emitter leg is on the right, the base is the middle leg, and the collector leg is on the left. This situation is reversed in case of a PNP transistor. Here the arrangement is the emitter towards the left, then base, and then the collector. Next, let us take this commonly used metal-capped transistor. Now, each of these transistors have a notch in them. This is an NPN transistor. If we are moving in an anti-clockwise direction from the notch, then we will first encounter the emitter followed by the base and then collector. If it was a PNP transistor, then moving in an anti-clockwise direction from the notch, we would first encounter the collector, then base, and then the emitter. Now, if you were given a transistor and asked to identify whether it is NPN or PNP, how would you do it? Well, it's simple, but for this, we will need a multimeter. Let us take this unknown transistor. Now, if we place the negative probe of the multimeter on the middle lead and the positive probe on either the left or the right lead, and if a voltage is produced, then the transistor is a PNP transistor. Conversely, if the multimeter were to show a voltage when the positive side of the probe was placed on the middle lead and the negative probe at either side, then the transistor would be an NPN transistor. Now, wasn't that easy? Well, with this, we'll end our video on the functions of emitter, base, and collector of a transistor. See you in the next video. Until then, stay tuned and stay safe. Bye.